Hello students, today I am going to explain you how to find the general formula for a sequence. I have made 3 videos earlier also. In that I had taken a different approach, and now this is a different approach of getting the general formula for a sequence. So let's learn, because this is in tabulated form, that is much easier. So I thought that let's make one more video so that we all can understand the concept much easier way. So let's proceed. I have taken 3 examples here. So let's take one by one and identify. First we have to identify the sequence, like which type of sequence it is. Like if we get our first difference equal, then the sequence will be linear. So let's just note it, like if we get first difference same, then our sequence will be linear type. Okay, that means that it will be of an plus b type, that we will come to later. Okay, and then if we are getting second difference as same, if second difference is same, then the sequence will be quadratic type. Quadratic means it will be like somewhat an square plus bn plus c type it will be. Okay, so let's find out by taking the examples. I'm taking the first one. Let's find out 11, 17, 23, 29. So let's see what's the difference between the two consecutive terms. 17 minus 11, 6. Then 23 minus 17, again 6. Then 29 minus 23, again 6. So this is my sequence and this is my first difference. So here we have got first difference only same. It means that the sequence is a linear type. Okay? This is a linear sequence. 11, 17, 23, 29 is a linear sequence. Now let's make the table. I will write here n, and since I have 4 terms, 1, 2, 3, 4, so let's write here, make 4 columns. Okay. Now I will give the symbol un for the terms. So my un, that is n equal to 1, is 11, then 17, third one is 23, fourth one is 29. And as I know that the difference is 6, so here we will compare with 6n. Let me write it properly, un, and we will compare with 6n now, this un. Okay, so 6n, it means n equal to 1, so it is 6 1s are 6, 6 2s are 12, 6 3s are 18, and 6 4s are 24. Now what we have to do is, we have to compare our un, that is the terms of the sequence, with 6n. We see that if I add 6 to 5, 5 to 6, then I will get 11. If I add 5 to 12, then I will get 17. If I add 18 to 5, I will get 23. It means that by adding 5 to 6n, I am getting my un. Okay, so what happens? My un will be what? It will be 6n plus 5. Understood? So this is of this format, an plus b. Okay, so my a is what here? This is of the format un is equal to an plus b. So a is what? A is 6. It means that a is the common difference. Remember, a is the common difference, that which was 6 here. I hope it's clear. Okay, fine. So now let's move to our next sequence. Okay, I will write it here. will need some more space, so I am making this way the partition. Second one I am taking, that is -2, -2, then 0, 4, 10, 18, 28, 40. Oh my god, there are a lot of terms here. See, 1, 2, 3, 4, 5, 6, 7, 8 terms are there. So we have to make 8 columns. No worries, let's make n. So here it is 1, 2. Wait, first we have to identify. I'm sorry. First we have to identify like which type of sequence is this. Okay. So you see, -2 minus -2 will be 0. Then 0 minus -2 will be 2. Then 4 minus 0 is 4. Now 10 minus 4 is 6. 18 minus 10 is 8. And my next difference is 10, and then it is 12. So you can see very clearly first difference is not same. So we have to proceed further. That is, now let us take second difference. 2 minus 0 is 2. 4 minus 2 is 2. 6 minus 4, 8 minus 6, and so on. We will be getting our second difference same. Okay? So our second difference is same in this case. So can you tell me which type of sequence is this? Yes, it is quadratic one, because here second difference is same. Okay? So now for this second difference one, it means that this sequence is n square type. Okay? Let's make the columns now. So n, 1, 2, 3, 4, 5, 6, 7, 8. Now let me write the terms. Un, that is -2, -2, 0, 4, 10, then 18, 28 and 40. Okay? Now what we have to do is, now we will write n square. N square. So n is 1. So this is 1. Then 4. 3 square 9. 4 square 16. 5 square 25. 6 square 36. And then 7 square 49. 8 square 64. Okay? Now what we have to do is, we have to find un minus n square. Un minus n square, or we can do n square minus un. N square minus un, that is 1 minus -2 is 3. Then 4 minus -2, that is 6. 9 minus 0, 9. 16 minus 4, 12. 25 minus 10, 15. 36 minus 18 is 18. And then it is 21. Then it is how much? 24. So we can clearly see this is 3n. Multiples of 3. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, and so on. It means that we are getting n square minus un equal to 3n. Now what we are interested in, we want un, the general formula for our sequence. So let's adjust it to get un. I will bring this here and this here. So n square minus 3n will give me un. This will be the general formula for this given sequence. So Isn't it easier method than the earlier one in which we used to write an square plus bn plus c, and then we used to compare a plus b plus c equal to the first term, then 3a plus b this term, then 2a equal to this term, and then we used to calculate a, b, c, and then finally put into this and calculate the un. So I found this one easier. So you can opt either of the methods. So in general, this way you can do. Let's take one more example. Why I am taking is to make this term clearly that everywhere we will use n square only or something else. So it's better to take this example. I will write here. Third one, that is -7, -4, 18, 17, and it is 28. So first we have to identify the type of the sequence. So let's find out the difference. -4 minus -7, that is 3. 18 minus -4, 18 minus -4 is 22. Then I'm sorry, it's 1 8. That's why I thought some mistake is there. 1 8. So 1 minus -4 is 5, then 8 minus 1 is 7, then 17 minus 8 is 9, and then 28 minus 17 is 11. So this is my first difference and it is not same. Let's find the second difference. This is 2, here also 2, here also 2, and here also 2. So my second difference is 2 here. So again a similar type only, not much difference is there in these two questions, but still I will take one more example later on. First solve this one only. So we will make the columns n, un, then n square, then n square minus un. So 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 terms are there. So let's write the terms. -7, -4, 1, 8, 17, and 28. So now n square, that is 1, 4, 9, 16, 25, 36. Now n square minus un, that is here it is 1 minus -7, 8, 4 minus -4, 8, 9 minus 1, 8, 16 minus 8, 25 minus 17, 36 minus 28. So everywhere we are getting the same term, 8 only. It means that n square minus un, we can write here n square minus un is equal to 8. It means what is our un? Let's just shift. So n square will be n square minus 8 will be our un. Clear? Okay. Now I am taking one more example. For that I have to rub this and then wait. Let me write the question. The sequence will be of different type. 0.5, then 2, 4.5, 8, 12.5. Okay, let me rub this. So fourth one I am taking sequence. So let's write here clearly 0.5, 2, 4.5, 8 and 12.5. Now let's find the difference. So 2 minus 0.5 is 1.5. Can we pause it? So now first we are finding out which type of sequence is this. So let's take the differences. So 2 minus 1.5 is 1.5. Then 4.5 minus 2 is 2.5. Here it is how much? 8 minus 4.5 is 3.5. Then here it is 4.5. So this is our first difference, and which is not the same. It means that we have to find out the second difference. Let's find. It's very clear. 2.5 minus 1.5 is 1. Here also 1. Here also difference is 1. Okay. So second difference is same. Now again we will make, so it is n square type. That is, it is quadratic sequence. Okay. So now let's make the table. N, 1, 2, 3, 1, 2, 3, 4, 5 terms are there. 4 and 5. Let's write the UN, our terms. They are 0.5, 2, 4.5, 8 and 12.5. Now here, what we have to write here in place of n square? See, here the difference is 1, 1, 1. Okay. So what we have to remember is that the coefficient of n square is half of the common difference. So since our common difference is 1, so the coefficient of n square will be equal to half, because half of 1 is half, or we can say it is 0.5. In earlier cases we saw that the common difference was 2. So half of 2 is 1. That's why we used to write here n square. But here in this case our common difference is 1. So we have to take half of n square. It means that here we will write half n square. In place of n square we have to write here half n square. Okay. So half of 1 square is half only. That is, we can write here 0.5, and then half of 2 square, that is half of 4, so it is 2. Half of 3 square, half of 9, that is 4.5. Then half of 4 square, 16, that is half is 8. Similarly, half of 25 is 12.5. Okay. So you will see that here half n square, by getting we are getting the same terms back. We have to do half n square minus un. Okay. So 0.5 minus 0.5, everywhere we will get zeros only. Okay. It means that half n square minus un is equal to 0. This implies that our un is equal to half n square. So I just took this example to make this thing very clear, that coefficient of n square here, the multiples of n square should be taken like this. Coefficient should be half of whatever second difference we get. Please remember this thing, and then the rest things are same only. This method is much more easier than the earlier one which you saw in my second video. Thank you. If you have any other doubt, please call me. You will see my contact numbers below. Thank you.